Today, we're going to explore linear equations in one variable, focusing on their meaning and context. In this video, we'll take a closer look at how linear equations can represent real-world scenarios. By the end of this lesson, you'll be able to read an equation and know exactly what it's telling you about a given situation. Here's what we'll cover today. First is how to interpret the meaning of constants and variables in a linear equation. Next is how to relate the equation to real-world situations such as cost, distance, or quantities. Let's get started. Now that we've introduced the topic, let's explore what it means for a linear equation to represent a real-world scenario. A linear equation in one variable is an equation that describes a straight-line relationship between two quantities. In real-world problems, these quantities can represent things like money, distance, time, or items. The key is understanding how constants and variables correspond to real-life meanings. In the equation 5x plus 20 is equal to 80, the variable x might represent something like the number of hours worked, while the constants represent fixed amounts, such as hourly wages or additional costs. In this case, the 5 could represent $5 per hour, the 20 could represent a one-time fee, and the 80 could represent the total amount earned or owed. The most important thing to remember is that linear equations let you model and solve real-world problems by turning words into math. By identifying the meaning of each part of the equation, you can interpret and solve problems effectively. The key idea is that the variable typically represents an unknown quantity, while constants represent fixed amounts in the context of the problem. By the end of this video, you'll know how to interpret the meaning of each part of an equation and apply it to real-world situations. Let's get into our first example. A mechanic charges $40 for a service call and $25 per hour of work. If a customer's total bill was $115, how many hours did the mechanic work? Let's break this down step by step. First, we need to define our variable. The question asks how many hours the mechanic worked, so we'll let x represent the number of hours. Now, we can set up the equation. The mechanic charges $40 just for the service call. An additional $25 is added for each hour worked. All this totals to $115. So, the total cost equation looks like this. Next, let's solve the equation to find x. First, subtract 40 from both sides to get the following. Now, we'll divide both sides by 25 to isolate x. So, the mechanic worked for 3 hours. Let's check our answer by substituting x equals 3 back into the original equation. Therefore, the mechanic indeed worked for 3 hours. For our next example, let's tackle a real-world SAT-style problem. A gym membership costs $20 per month, plus a one-time registration fee of $50. If your total payment for the first year was $290, how many months of membership did you pay for? Let's break this problem down step by step. First, let's define our variable. The question asks how many months the membership was paid for, so we'll let x represent the number of months. Now, we can set up the equation. The total payment of $290 includes two parts: a one-time registration fee of $50 and a monthly charge of $20 per month for x months, giving us the following equation. Next, let's solve the equation to find x. First, subtract 50 from both sides. Now, divide both sides by 20 to get the number of months. So, the membership was paid for 12 months. Let's check the answer by substituting x equals 12 back into the original equation. Therefore, the correct answer is C, 12 months. Great job working through these examples. Let's quickly recap the key ideas you've learned today. First, we learned how to set up and interpret the meaning of constants and variables in a linear equation. Remember, the variable typically represents an unknown quantity, like the number of hours worked or months of membership. Constants represent fixed values, such as totals, one-time fees, or time-based rates. We also saw how to translate real-world problems into equations and solve them step by step. You learned to isolate the variable by performing operations like addition, subtraction, multiplication, or division on both sides of the equation. Great work today! Keep up the momentum and see you next time.